And it looks like you got the right answer. You just didn't provide the correct units for this. The correct units here would be in feet. Is that okay?
Yep.
Okay. Now, so let's actually do this. And well, this actually will take a fair amount of work. Maybe we won't do that. So the other question it could ask, there's always two questions you could ask when you're doing a vertex. And one of the questions is, where is it and what is it? All right, so the second question is like exactly the same, okay, as the previous one, but this time they want to know the time to reach the maximum height. So if we go back to our graph, there's really two values here. There's the x value, that's the time that it took, and then there's this y value, which is the height. So the height is what it wants in question one. The time is in question two, the time it takes. Okay. Now, to answer this question more directly, to actually do it here, you have to recognize that this equation is already in what's called vertex form. I think we've talked about that a little bit. But vertex form is this. It's x minus h squared plus k. Sometimes there's a number on the outside. So take a look at your problem here. Do you see how it's more or less in this vertex form here?
Yes.
Okay. So what is the value of h in this problem?
1/4.
1/4, perfect. And what's the value of k?
49.
49. So this gives you, it actually gives you the two answers you were looking for here. Okay. The 1/4 is the time, and the 49 is the height.
Okay.
So we could graph it, but it's given here. Now the only issue you had is that you gotta provide the correct units for these potential problems here. All right. So where it gets a little bit harder is when you are not given it in vertex form, like in this next question here. So notice this time around, they're giving you the quadratic in what's called standard form.
Okay.
So in standard form, again, you could graph it. You could graph it here and just find these 2 points. I mean, I would definitely recommend that. But there's also some formulas that you can use. What do you think you would use for this problem? If you're asked to do it again, would you graph it or would you want to use formulas?
Probably formula.
Okay, so let's do that. So the x coordinate of the vertex is what's called it's at what's referred to as minus b over 2a. And you might be thinking, well, what is a and what is b? So in standard form, it's ax squared plus bx plus c. So the a value, the a is what's in front of the x squared term. So what number is in front of the x squared term in this problem here?
-16.
-16. How about b? That's in front of the x term or the t term.
96.
Okay, and we don't need it yet, but what is c? Let's just say we did need it. 100, perfect. Okay, so to find the x coordinate of the vertex, you need minus b over 2a. Minus b is minus 96 over 2 times minus 16. So this ends up being minus 96 over minus 32, which is 3. Now, what are the units in this problem here? And they sort of tell you up here. What are the units of t in this problem?
T.
Yeah. Read this to yourself here. The height of, go ahead and read that to yourself and see if you can tell me the units of t.
3.
Say that again.
3.
That's the number, the units. We want the units.
Oh.
Units. Units means like, what are we measuring it in? What word am I hinting at here?
Seconds.
Seconds. So yes, the answer is 3, but they want you to write 3 seconds.
Okay.
Okay, now the height, they actually don't tell you that the equation is in feet, which is actually odd. They should tell you that. But the height here ends up being 244, but you have to write 244 feet. Okay, so what you'll have to do here is really just pay attention to those units when it asks for them with your answer here. All right, so that was from workbook 25.3. Let's go back and see if we can grab another workbook assignment and take a look at some of those questions. Of course, it's not loading. Try this a different way. Okay, so this one is, maybe we did this already, creating a vertex form equation. I think we were doing some completing the square stuff last time. Is that true? Maybe?
Yes, it is.
Okay. All right. All right, so now let me just show this question to you. You got it right, but I'll make some comments here with how you can do it. So there's always a couple of different approaches. Get this snipped in. So again, this Emilio's throwing marshmallows into the air from his balcony. He's probably bored, and they give the equation and they say, all right, here's your equation. This one is in what's called standard form. Okay. And all of these equations here are in what is called vertex form. So one option, Jeremiah, would be to literally graph all 5 of these, the 4 answers and this one, and see which 2 were exactly the same. Okay. But that's not your completing the square approach to this problem. Another problem, if you notice, if you actually look at this part right here, do you see that all of these there's some differences there and then differences here?
Yes.
You could compute the vertex from the standard form. You could use that formula again, that minus b over 2a. And that's what we'll do to determine the vertex for this problem, and then matched up with one of these answers over here. So can you tell me, again, it's ax squared plus bx plus c. Could you tell me the value of a, b, and c of this standard form equation?
Okay. A is -16.
Okay.
B is 8.
Got it.
And C is 48.
48, perfect. All right. So minus b, that's minus 8 over 2 times minus 16. If you use a calculator, be sure to put extra parentheses around the denominator. Okay, so this ends up being minus 8 over minus 32, which is 1/4. So that gets us down to B and C. Can you see why? Can you tell me why it's B or C? It's this value right here.
Okay. 1/4.
Yeah, the x coordinate of the vertex is 1/4. These both have an x coordinate of 1/4. Okay. Now the one thing that they probably didn't tell you, but it's extremely useful here, between standard and vertex form, there's one thing that's exactly the same with them. I'll see if you can identify it here. What is exactly the same about both of them?
They're both negative.
This letter A right here is the same in both.
Oh yeah. Okay.
Okay, so like in your problem, what's the value of A? You already told me. Minus 16. So you want the equation that has minus 16. So that's another way to do it. You don't have to complete the square. You can. It's just not, usually the best approach here. Okay, so let's do another problem here. Let's do this vertex form stuff. I'll have you jump in here at some point and try some problems, but there's a lot of words here, but all I want us to do is focus on this equation right here. And I want you to find the vertex. Okay, I want you to find x equals minus b over 2a. Can you do that for me?
Okay. Um. -32 over 2 -16.
Okay, can you reduce that?
Yes, by, uh, 3. Can you reduce 3 by 32?
It feels like you didn't write this down. I mean, if I'm wrong, tell me that, but did you write this down?
No, I tried to do it in my
Okay.
head.
Yeah, try writing it down or now that it's down here, keep going here to the right. I need you to reduce this for me.
Okay. Um,
So the numerator is minus 32. What is 2 times negative 16?
7.
You're multiplying, Jeremiah. 2 times 16.
-32.
Yeah, negative 32. So when the top and bottom are the same,
A equals 1.
1, perfect. Okay. So this is the x coordinate of the vertex. This is actually your h value. We wrote a x minus h squared plus k. So this is your h value. So it's x minus 1 squared. And I mentioned this before, the a value is exactly the same. So you bring that down minus 16. Okay. And that should be enough to get you the correct answer in a lot of these. Maybe not every one, but a lot of them for that. All right, so let's see here. Guess I'll give you some, like we can maybe look at another couple of problems here. Is there any opportunity to redo the exam or retake it?
Yes.
Okay. Let me see if I can pull up some of those questions for you. Just looking, scrolling through it here. I mean, will it be the exact same questions with just mixed up answers, or is it going to be totally different questions?
They'll be the same, questions, but the answers should be in different order.
Okay. All right. I've already kind of done this one. Okay. Sorry, just give me a moment here to get these pulled up again. All right, so let's. Just look in here, see if there's any like the ones we just did. Yeah, actually, there is one that's exactly like what we just did. Okay, we'll just go through these from start to finish, see if we can make some sense of this. Okay. Question 1. All right, so this one, it says which equation shows the correct factors for the quadratic equation 24x squared minus 15 equals 54x. Okay, so whenever you're doing anything with quadratic equations, you always want to bring all terms to one side of the equation. Okay, so in this case, you're going to subtract 54x from both sides because you want to move that from right side to the left side. So your result is 24x squared minus 54x minus 15 equals 0. All right, so from here, the very first type of factoring you always want to do is what's called the greatest common factor. And it could be a number or a variable, or it could be both. So let's start with the number. Is there a number that goes into each of the numbers 24, 54, and 15?
I think so.
There
3.
definitely is. 3. 3 goes into all of them. That's 8x squared minus 18x minus 5. Now what's interesting is if you chose the wrong number or not one that's big enough, you would just do it again. But this is good now because there's no number that goes into 8, 18, and minus 5 equals 0. All right, so from here, the technique here is to multiply the 8 and the 5 together, 8 and negative 5 together. 8 times negative 5 is negative 40. Right, and you want to find two factors that multiply to negative 40, but now add up to this middle one, negative 18. All right, so to do this, you would just write all the possible factors here. Negative 2 and 20, 2 and negative 20. Let's see here, negative 4 and 10, 4 and negative 10, negative 5 and 8, 5 and negative 8. So do any on this list add up to negative 18?
No. Wait, negative 18.
Yes. So the one I've circled there, I mean, you gotta work through that list to figure that out. But reason you do this is you break apart minus 18x into 2x minus 20x. And you bring the 8x squared down and the minus 5 down. And then we did this a couple of weeks ago. Now we do what's called a factor by grouping. So you look at those first two terms and you ask yourself what's common between those first two terms. What goes into both of those terms? We'll start with a number. Is there a number that goes into both of those terms?
2.
2. And how about the lowest exponent between the x squared and the x?
1.
1. So 2x goes into both of them. And then you're effectively dividing both of these by 2x. Can you tell me what 8x squared over 2x is?
4.
4x, the one of the x's cancels. How about 2x divided by 2x? It's the same as that when we did earlier, minus 32 over minus 32.
1.
Plus 1, yep. Now you immediately write whatever's in parentheses off to the right here, and you try to figure out what goes in this place that I'm indicating here, such that when you multiply in, you get back to the previous line. And usually it's best to look at that number. Like, what do you multiply 1 by to get minus 5?
I'll multiply 1 by minus 5. Negative 1.
Negative 1 gets you negative 1. Negative 5 gets you to negative 5. You're taking negative 5 and multiplying it by 1.
Oh, okay.
Okay, now the question is, does it work for the 4x? Minus 5 times 4x is minus 20x. Yes, it works. So because it's factor by grouping or double factoring, you have to factor again. Both of these have a 4x plus 1 in there, 4x plus 1, 2x minus 5, and then you bring the 3 down. Okay, now again, kind of like in full disclosure here, what could you have done when you saw a question like this on the exam? You could move this term over like we did, and then you could start graphing these and seeing if they're the same. But you got to get all the terms on one side. Okay, let's look here at another question here. So I know we did something like this at one point. It's a table problem. Thought maybe even you liked it. Like this type of problem. All right. It says use the equation y equals minus 2x squared plus 6x plus 8 to complete the following table. So the mistake here is to try and do it by hand. You really want to use a calculator if you can. You are allowed to use a calculator on these things?
Yes.
Okay. So what I would recommend is that Desmos scientific calculator. And if it's been a while, let me just pull it up and we'll work on one together here like this. And I'll show you kind of the shortcut for working on it. So I pulled up, there it is. Okay, so I'm gonna share my screen or share another screen here. Let's go new share, share that, got it. Okay, are you seeing the calculator screen?
Yes.
Okay, so if I write minus 2x squared plus 6x plus 8, like this means like I don't understand what you did. And it even tries to help you. It says too many variables, try defining x. Okay, so what you could do here is you could write x equals -1. Okay, and then it kind of knows what to do because it's like, oh, x is -1. This is better than you trying to fill in x up here because you don't have to, you can just make the change here. You can say, oh, x is 0, x is 1, x is 1.5, and so on. And that allows you to fill in your table. I think that's pretty intuitive to do. So again, I would recommend using this. I'll throw this in the chat and see if you can do that. Now, when you're looking at the answer space, let me go back to the other screen here. When you look at the answers, you sometimes just need to identify what's the same and what's different between them. So when I look at the answer space here, maybe you're already doing this. Wouldn't surprise me if you are, because it's a good solid technique here. So notice, like, if the first number is, you can see that in the first column here, they're all different. So you definitely need to check the first number. And then you might look for another number where they're all different. Okay, like the third column only has 3 of them that are different. And that's for the third number here for +1. So the idea is like you could start checking off. Like we figured out that when you put in 0, I'm sorry, when you put in -1, I believe we got 0. So these two answers were out. And so you're looking at it, you're like, okay, 0, 0, 8, and 8. I better go to that third one because that's what's different. That third one is when x is 1. And that way you're not, calculating them for ones that are going to be the same each time. Okay, let's look at another question here. Oops, sorry, still sharing this. Meant to snip. All right, so this one says to factor the quadratic equation. So we're going to do that here. We're going to write the quadratic equation. And the very first type of factor you always try is what's called the GCF, greatest common factor. So is there a number that goes into all 3 terms?
2.
2. 2, get x squared plus 4x minus 77. Does that sound right? Yeah. Okay. Now this time, because there's a 1 here, we don't have to multiply. We need to find 2 numbers that multiply to -77, but add up to +4. And at first glance, you're like, oh, that there's nothing works. Because like 2 doesn't go in, and 3 doesn't go in, and 4 doesn't go in, 5 doesn't go in, and 6 doesn't go in, but 7 does. Okay, and then 8 and 9 do not work, and 10 does not either. So do any of these add up to +4? And you're adding horizontally.
-7 and 11.
Perfect. So that becomes x -7 x plus 11. And you have to set each of these equal to 0. So x equals 7, x equals minus 11. So it looks like on this problem here, you did not sure actually, because it just closed out, but just be sure to give it what it's looking for. I think it wanted like x equals something else. Okay, this one actually wanted the line of symmetry, but that's okay. We can talk about that another time. So you actually, you'll see the answer that's -2, but this was good for us to try and for you to see for some factoring. All right, Jeremiah, that is it for tonight. We'll get back on schedule next or tomorrow or Thursday. We'll just keep going through this stuff. And if you ever need help with something specific, please let me know. And that is it. I'll see you in a couple days.
Okay, bye, Matt.
You're welcome. Okay, bye now.